able to continue somehow the development, because it has been like 1 month or more, right? So yeah.
Actually, the Macau outbreak of the pandemic has been started for about 20 days. About 20
Okay.
days. So
Okay.
actually, before that, we have planned a live demo, and for the live demo, we would demonstrate a more whole
Yes.
presentation, and we would include things like borrowing the books, and also we would have more functions. But unfortunately, due to the pandemic, we were not able to do that. So we could only do a simulation.
Yes. 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 I think it has been
Planned
not
a lot
easy.
of
Yeah.
functions before. Yeah.
How do you actually get this idea about library? Is it it's a particular request from the school, or yeah, I'm just curious about how you get this idea that you want to implement service robot in a library.
We were inspired by the COVID-19 because it is one of the most controversial topics in recent years, and libraries are a typical type of public facility, and due to the pandemic, many public facilities needed to be closed or controlled, and therefore we need many people to help us do that. But so we would hope to. So our goal is to create a zero-touch library service with technology and to help people and to bring convenience to people during this severe time.
Yeah, and I'm just curious if you have ever talked to the school about the possibility to let you even do a trial or a pilot at your school's library.
That is one part of our future thoughts, and we have been thinking about this point, and we would like to try to do this if we have a chance in the future.
Yeah, I think that would be better or good for you to also collect data and to test and to test the models and the assumptions that all you make, right? Okay. And okay. So if I understand correctly, you just also mentioned about last year you used RGBD sensor and this year you use SLAM. Remind me again, are there any specific like enhancement to the hardware for this year competition that you specifically do apart from LiDAR?
We changed the screen to a larger screen, and yeah, user can see the screen more easily. And
okay, yes. So so there's a screen, a SLAM, and the height and position of the manipulator. Okay, so yeah, yes, very very impressive, I would say.
Also, for the hardware, this year we have 2 Astra cameras so that we can separate the different cameras for different function.
Oh, okay.
And also the distribution of the components in the robot. We arranged the positions of the components in the robot so that people can feel more comfortable when interacting with it. Also, the repairing will be much easier because the distribution is planned so that it can be more convenient for us to repair it.
Yes. So you say the Astra camera, do you mean there are 2 at the bottom, or is it 1 above and 1 below?
Right? One for the manipulator depth camera for manipulator to grab things, and one for object detection.
Okay. Great. Yes. Oh, and if you were to test it in the library, right? So have you thought about like the battery life circle? How long would you need to charge it, right? If you were to do a test or even to have it implemented for the functions that you have designed? Is it going to be intensive? That is taking a lot of resources, or is or your experience up to that point where you are able to get access to the robot?
Well, our robot can actually like work for quite a long time
Mm.
and with only one battery. So we don't need to change a battery for time.
Okay.
Frequency.
The robot can run for an hour and a half without charging.
Okay. Great. Yeah, I think that is. I mean, overall, I think we are impressed that you still continue to do this development and join the competition despite the very challenging situation in Macau. So yeah, we would like to thank you again for your participation. And we have 1 more minute before we go to the next team, which is also from Macau, right? It's FarmBot. Yes. So let me see. Yes, I think it's your colleagues, right? Actually, we have 3 teams from Macau Pujing Middle School this year. Yes. Okay. Any final comments for a few seconds? But otherwise, yeah, we are happy. To invite the other teams to join. Thanks a lot.
Thank you
Try
for
forever.
listening to our presentation, and sorry for the inconvenience caused. We will keep trying.
No worries. Yes.
Thank you.
Stay healthy. Stay safe. Okay. And continue this learning of AI and robotics. Thank you. Okay, so let's welcome the next team from FarmBot, Macau Beijing Middle School. You may share your screen now. And start the presentation.
Okay. So dear judges, teachers, and students, good morning. We are FarmBot from Puiqing Middle School. Today, we'll be presenting our robots and some functions for a gathering, which is the title of our presentation, A Master's Daughter's 100 Days Banquets. Before getting started, we would like to inform you that the epidemic situation in Macau has been severe, so the government announced to end the school year early and launched a citywide nucleic acid test program. The locations of the test stations include our school. We have to follow the government's guidelines, so we are unable to practice the exhibition. We felt so sorry for it, but luckily we can do an online exhibition. Let's get started. This is our table of contents. First, I will introduce our team. Then, I'll be talking about the intention of making the robots. Next, we will be talking about the hardware structure and software. After that, we will go on to the background setting and exhibition of the robots. In the end, we will come to the conclusion. This is our teammates. Our team leader is Leung Chi Mei, Coco Leung. This is our team photo. Our team name, FarmBot, stands for 6 words: faithful, accurate, mindful, brilliant, omnipotent, and talented. Summer vacation is coming, and it's time to invite friends and family for gatherings. But sorting out various arrangements, such as the food to be prepared and the guests to be invited, is hassling and tiring. In order to save time and be efficient for arranging gatherings, we decided to make this robot to help us out. Now let's talk about hardware. I'll briefly introduce some important parts of hardware. We got a rear speaker, Jupiter camera, Jupiter robot, emergency button, screen, robotic arm, speaker, and leader. Inside the chassis, we got battery, motor, and microcomputer. I will now talk about why we choose to use Jupiter Robot now. Let's talk about the benefits first. We think Jupiter Robot is small volume, which is convenient for us to install. Second, it's possible for us to change the host. Third, which is a robot with a camera. Due to the fact that the Jupiter Robot has a built-in system. Therefore, we could take it off from our robot and connect it to our computer, which we can program it at home too. So for hardware, we'll have
黐線啊佢搞
orientation
機。
function and face
喂，你
control.
我睇翻 live，我倒退翻之前睇緊啲 Q&A 咯。
So first of all, let's talk about the convenience part. The conversation functions is
變咗
used
Jerry 啊而家。
with the guest for the purpose to know what the guest order is. As you can see on the left side of the PowerPoint, this is the program we have written for the conversation. The program has included 3 main parts. First, we will use load data function to import the text file, which has included the question, answer, and keywords for question. After that, we will use the answer functions to determine whether the results returned by Emma Voice is similar to the question we set. And finally, return the answer to the question. If the question is an order, then the robot will ask you what the guest has said. As you can see in the PowerPoint, this is the part of the text file which includes the question, answer, and keyword for question. The first line is the question. The second line is the answer, and the further lines are the keywords. We use comments to determine the or condition, and use line breaks to determine the end condition. Second of all, we will introduce the face recognition function to you. This function is used for determination to find the location of the face in the image and converts the face image to a feature factor. Lastly, we will compare the pre-saved feature factor, which is the current one, by using the mathematical formula. As you can see on the right side of the PowerPoint, this is the explanation of how our program functions. So now I'm going to talk about the background setting. We distinguish the background setting into 2 parts: characters that we need in our setting and the process of the task. For characters, we need a robot, a master, guest A, who is the master's friend and was identified by the robot, and guest B, who is the master's friend but wasn't identified by the robot. We will now talk about the process of the task. So first, the master and the robot will select those dishes that they are going to make in the kitchen. When a guest comes and knocks on the door, the robot will go to the door and check who the guest is. Then, the robot will go to the door to guide those guests into the living room. Last, guests will be staying in the living room when they're waiting for the dishes. We designed the program into asking the master no matter if the robot can identify who the guest is or not, because like guest B, for example, who is the master's friend but not identified by the robot. So to make sure who that is, we decided to ask the master's idea. The differences between them is when the guest is identified by the robot will say out the guest's name. So now, we are going to present an exhibition of our robots. As the lockdown is going on in Macau right now, we will choose to use VM and online exhibition. Let's get started.
Now the master is discussing with the robot about what to prepare for the tonight feast. So the master asked the robot, "Hey robot, what dish should we make for tonight feast?"
Making a hot pot tonight because I heard that your friends love it very.
But the master didn't know who is outside the door. So the master asked the robot, "Hey robot, can you help me to see who is outside the door?"
Sure. Dear master, Raisin is outside the door. May I go to open the door?
The master said, "Yes, please."
Sure.
Therefore, the robot go to open the door for Raisin. And as you can see, here is a camera. But in original, this camera should be put next to the door. But because of the epidemic, we can only use VM for our robot exhibition. But in the VM, we cannot put one more camera next to the door. So We use computer webcam instead of the camera that put next to the door.
Welcome. Hello, Raisin. My master is preparing for the dinner. Let me take you to the living room.
Raisin said sure to the robot, and the robot lead Raisin to the living room.
We arrive. If you need any help or serving, you can ask me.
Raisin said sure to the robot. After that, the robot go back to the kitchen to help the master prepare for the feast. Later, Chester come to the door and lock the door, but the master didn't know who is outside the door. So the master asked the robot, "Hey, robot, can you help me to see who is outside the door?"
Sure. Master, there is someone outside the door. May I allow this person to go in?
The master said, "Yes, he is one of my friends, Chester. Let him come in."
Sure.
And the robot go to open the door for Chester.
Welcome, Chester.
And the Chester said to the robot, "Hey, hello, robot. May I know where is your master?"
My master is preparing dinner in the kitchen. Let me take you to the living room.
Chester said sure to the robot, and the robot lead Chester to the living room.
We arrived. If you need any help or serving, you can ask me.
Chester said sure to the robot, and at last the robot go back to the kitchen to help the master prepare for the feast. And this is our exhibition.
Okay, thank you. Any questions or you have anything to add? Yes, please.
Yes, got like this is the end of our presentation, and we felt so sorry for the mistake that we made just now. Like one of our group mates can't open the mic, so we would like to apologize for that.
No worries, no worries. It's okay. Thank you. No worries. Okay. So, any questions to the team?
Yes, I have one question. So I saw, sorry, I could not remember the name. So one member of the team just explained the story to us. At the same time, they talked to Robert, and Robert responds. So I just want to understand, how do you switch on and switch off this part? I mean, so how Robert know which word you're talking? They should recognize and respond, and which talk they should not.
Hello, judges. Can you hear me?
Yes.
Yes.
Well, we use the MR voice to determine what the operator is saying. So MR voice is a software package which is made by us, which is used as a speaker that we use to get the conversation. When we are saying something to the robot will record the audio and upload the audio to the internet by a model called speech recognition and identify the audio's on content. After identifying the content, the MR voice will return the word to a topic of the speaker. So we have a text file which includes some keywords of the question. So if the words is included some keywords of the question, so the robot will respond it.
Yeah, I understand this function. But the question is, you are explain the story to us, and then you talk to Robert, and Robert responds. I'm just wondering, how do you switch on the voice recognition function of the robot? So how Robert knows this word you're talking to him, and the other things you're explain the story to the judges or teachers, to others.
Okay, sorry for misunderstanding the question. So the reason that why we can switch it off and switch on is that when we are executing one function, I mean when we are moving to add the other place, so we cannot receive any audio and response it. So whenever we stop on a point, we can start receiving the audio. So this is why we can explain the words, and at the same time we can control the robots. Yeah.
Okay. And so that is function there.
Yes.
Okay. Thanks for the answer. I don't have any other question.
Yes, thank you. So any other questions from anyone here? Or yes, same from us. You are also from Macau. Tell us probably the challenges that you are facing at this time, assessing the robot, or is it not really a problem because I saw you are using the small little device from Jupiter Robot? Yeah. So I mean, do you have problems assessing the robot, or you want to tell us a bit of your experience during this time?
Like we are fine actually because of the Jupyter robot. Like we can take it out from the robot and connect it to our computer. So it's definitely fine for us to code it in home, like at home. So it's fine for us.
Okay, so it's fine. So you're not much impacted, right? In that sense, so it's more.
Yes.
So all of you or all of your teammates have one unit of the Jupyter IO.
Pardon, may you repeat one time?
Okay. Yeah. Okay. Yes. So let's see. Yeah, I think it's a good thing that you can bring it home. So that means you're not much impacted, right? So that you can continue your development during this time. Okay, so 1 more minute to go before we invite the next team, Fitbot, right? Yeah. Okay, so yeah, thanks a lot again to the team FarmBot for the good job done during this challenging time. Yeah, let's welcome, or yeah, let's invite the other teams to get ready. That will start at 10:20 with Fitbot. Okay, so a few seconds to go. We'll start punctually at 10:20. Yeah. Okay, you may start now.
Can you see my camera?
Yes.
This is,
yes.
I think
I
it's
can
about,
see you and I can see the screen as well.
okay. So I'm going to start. Hello judges and everyone. We are FaithBot from Macau Preaching Middle School, and we are here to introduce about our robot. Our team has been working on robotic and scientific project, and we are going to show you our result and demonstration on the rest of our content. Before moving on to our content, which here showed, this is an emergency situation. Because of the sudden outbreak of the epidemic in Macau, we cannot go back to our laboratory for the live demonstration. Therefore, we are going to use a borrowed environment to simulate our live demonstration instead of taking the risk of going back to the laboratory for the process of our project.
With the help of teachers, we try to pick up new challenge and improve our teamwork abilities and projects. We continue to work for different kinds of events to participate in different competitions. Therefore, we need to break through the limit of using the previous robot and try different functions and components, like the new self-made chassis, the waving and the direction detection, so as to reach the goal of building our own service robot for indoor users, disabled, and the elderly. Here are the two main issues of the old robot: load-bearing capacity and stability of it. And the reason for building our own robot is simple, because we are just trying to solve and improve those issues. Besides, I'm going to introduce the design of our robot. As you can see, our robot base is using the FAX1, so is our frame. On the base, there are a few things. For example, the self-made chassis with the FAX components. On the next half layer, there is the battery for the robot. For the second layer, we put the LiDAR and the NUC. For the third layer, we attach a robotic gun. For the last layer, there is the camera and the monitor, and that's the whole design of our robot.
Moving on to the chassis part, and this is, first of all, I'm going to show you how it performs with some simple videos, and this is about the SLAM, tele control, and the path planning part, simple path planning part of our chassis. As you can see here, we are slamming our laboratory and trying to navigate in with a simple straight line. And this is the first try of the navigation. You can see the robot slowly plan to the destination and reach it. And this is the second test. And you can see there's a whole different path to plan to the same destination. And this is how our robot works. And here are the robot with turning parts. Also, you can see it's crossing the door at the end. And And after the real performance of it, I'm going to talk about the main technical points about it. We use change of API to connect between words and facts, which is the V5 brain, the motherboard of our chassis, so as to control the motor by different methods, such as the tail control and path planning that I mentioned. On the other hand, we created ROS-Node for the other nodes to operate with it. For example, the localization functions with the transfer data of those encoders. It calculates and starts the autumn localizations after getting data from the V5 brain. Thirdly, basically, with the new structure and new height of the robot, it could be more stable because of the bigger size and higher weight of the robot. On the other side, it also increased the speed of the robot because of using 4-wheel drive method instead of using 2 wheels. Combining those things, it can afford more components such as some tracking cameras and etc. Moreover, it will be more furious and customizable to fit in by launching in different functions and environment, which can apply to different groups of users. And here are the functions we have attached to our robot this time. As you can see, there are 4 functions and 2 of them are the voice recognition and the robotic arm. They are something old, yet the waving detection is the new activation methods instead of using speech recognition. And the direction detection can make the robot know about which way to go when users are not able to command with voice. And now I'm going to stop sharing my screen and pass it to another teammate.
Okay, so I'll take the mic from Simon right now. So as we have mentioned at the beginning, we have waving detection and finger detection this year. So I'm going to explain a little bit about it. So this year, we have used that MediaPipe as our solution. We have used MediaPipe's hand detecting solution and its pose estimation solution. So last year, for pose estimating, we have used that OpenPose for the pose estimation, but we find it's actually very slow. So these are data that we gathered on testing. So we run OpenPose on CPU and we find that it's only 2 to 4 FPS, which is a really slow and lacking speed. So on GPU, we find it's 25 to 30 FPS. It's a fluent speed, but this is recorded when OpenPose is the only one running on the GPU. In reality, we have more models running on GPU, such as face recognition, person detection, or person identification, etc. So the exact value of this one will be the same as on the CPU. So it's still slow. This year, when we discovered MediaPipe on the internet, we found that I'm now going to demonstrate waving detection and also finger detection here. So as you can see now on my camera here, my jaws are now captured by pose estimation by MediaPipe. So now if I just wave my hands like this, it can detect that I'm waving right now by the 3 jaws that is detected at here. So as for finger detection, I can just detect the 4 jaws at here on my index finger, and then it can just determine whether I'm pointing to the left or right now. You can just see. So we can have some applications of it. So before, when we have to activate our robot, we will just have to yell at the robot and just say, "Hey, robot," and then it will just activate the voice recognition. But this year with wave detection, we can just wave at the robot and then it will just activate with one, which is more easy and convenient. So now we will get into our live demo demonstration. I'll give the screen to my teammate, which is Simon.
Okay, and after the introduction of the waving detection and direction detection, here is the simulation of combining voice recognition and navigation functions in our environment. Let's go. And I'm going to open my program and test it. As you can see, I launched the program already, and I'm going to, and I active the robot already. Like, are you here? Do it again. It's ready to go. And now I'm going to navigate it to one of the bookshelf, or maybe 2 of them. Hello, can you go to the right side and get the book for me? So basically, as you can listen, it responds to users, and now it launched a task. And this is how the robot detects the keywords and plan to the destination, which is in front of the bookshelf right here. After reaching the point, it should be using the robotic arm to grab the book, but unfortunately, we can't show it right here, like in a full process. But it is fine though, I think. And consider that we still have some time. I'm going to test to the other destination, which is the left side. Okay, please, can you go to the left side and get the book for me? As you can see, the robot has planned the path from the right bookshelf to the left bookshelf, which you can see in the gazebo, which placed here, and in the area I said, which is the environment too. If you can see, the path is the green that's planned to the left bookshelf, and this is how the voice recognition and the navigation part works. Oh, as you can see, listen, it responds right now, and it should be returning to the users and going to give the book to the users or other things like instead of books. And by the way, the navigation part will be the same when users are waving to activate the robot, like not using the voice because of the distance problem or something. And the same as using pointing at left or right, just like how we say in a sentence, it will still publish the result like left or right, and the system will recognize the keyword in a topic and plan it to the destination, which left or right. So this is the end of the simulate demonstration, and we will now go on to the future improvement and conclusion part. I don't know if you can listen to the robot sound, but I think you can listen one more time. Like, are you here?
Yes, I'm ready to go.
Yeah, and this is how it responds to it.
Okay, very impressive.
Oh, wait. This is.
Yes.
Yeah.
Okay, please continue. Yeah, 3 more minutes.
For the future improvement part, the idea of this robotic assistance has a profound potential that significantly lessens the workload of the housework and brings convenience to the users. Yet, many educational institutes and companies are engaging in the work to further explore its potential and what the device is capable of. For our team, the improvement of the model body, as well as the robotic arm, will be our first priority to focus on, as the hardware design should be more dynamic and flexible, which enhances the swiftness and stability of the robot. In addition, besides voice and weapon recognition, it will be more recognizable if a facial recognition system is installed. It enables the device to activate when it sees its host. Moreover, anthropomorphism is a huge aim in the robotic industry. It is indispensable in the future when humanity has more interactions with robots. Therefore, our team will also work on the aesthetic of the robot, making it look more human-friendly and respond naturally during the communication. In a nutshell, our developed robotic device offers a variety of functionalities to help the user to do basic tasks on a daily basis. It greatly enhances the convenience for the user as the robot is equipped with the capability of waving detection, navigation system, voice recognition, and the communication algorithm, which enables the machine to deal with the according jobs. However, our project is not only just providing services to the households. The prospect of this robotic device is to contribute to different scenarios, such as aiding elderly or disability, or even acting as an office robotic assistant. Yet, more algorithms should be installed and additional functions should be developed to achieve the possibility of offering positive support to the society. This is the end of our presentation. Thank you for listening.
we are moving on to the QA session.
This
Yes,
is the end.
thank you. Thank you. Great, Bob. So
Yes.
questions from the jury or colleagues?
Yeah, there's several questions from Echo. So I saw there's navigation functions. I'm just wondering, how is the map created?
And the pardon, I'm not very clear about the last part that you said.
How is the map created?
Okay, so basically we use the SLAM functions, which using the RP lidar, and you can detect the features that the indoor environment are having right now, like in our laboratory. And using the RP lidar, you can detect it, and to create an indoor environment, which is the SLAM functions that I mentioned just now, and you can get a map right now.
Okay, so robots can create the map firstly, and then they will navigate in using their navigation function to do some instruction you're giving to them, right?
Yeah. But before the navigation, we have to finish the map first, like what you said, and the localization part. And we are using the AMCL and autumn localization to like basically we have these two functions so as to navigate in the map. Yes.
Okay, great. So the other question, I saw wave recognition was introduced. Just wondering, what about the accuracy, and how about the distance?
Well, I'll answer the question for now. So, for the accuracy, we haven't tested for a really accurate value, but by some of our tests, actually MediaPipe's accuracy is much more higher than OpenBoost that we used last year, and also the distance is far. We can just stand forward and distance maybe just like 2.5 meters away.
Oh, okay, 2.5 meters. Understood. Okay, so actually, I'm just wondering, what's the most difficult part you think during the whole project?
For in our team, the most difficult part, probably, I mean, undoubtedly is our chassis because it is a self-made. And why it is challenging and difficult because the bugs that show up when we are working on the chassis are way more than others, because this is something new for us. Like instead of doing the functions, this is something like need to combine a lot of things and need to research about it. Yes.
Okay, thanks for answering. I don't have any other questions.
All right. Thank you for the questions.
Thank you. Personally, I'm just curious that how long have you actually spent on this project? Did you join this as well last year and you built on top of the experience?
I have the experience. We have the experience on the functions, like those robotic arms, speech recognitions, something, and the camera, something like that. But on the self-made chassis, this is something new, and we just started like months ago. I mean, half of a year, like 12 of last year, and that is something challenging of us because of the time is not very enough for us, and we're just going to keep pushing ourselves to do this thing. So although we don't have a lot of time, like just what I just said, like half of a year, like 7 months, like until this date, I think it is like 7 months. And I think this is not a long time for us to prepare on this chassis and combine the functions, but we did it but unfortunately we can't show it like in the real demonstration. So this is a PT for us.
Never mind. We all understand the current situation, but I'm very glad personally that you still persevere and join this competition. So it's very, very good from your side. Okay, so I think if there's no other questions or you want to make any final remarks or comments, if there are any points that you just want to add.
Yeah, I want to explain something. I think I didn't explain clearly because the waving part is separate from the navigation part. But I want to explain one thing is because it is something same as what the voice recognition will do. Like after the active the robot with the waving detection is still the same, like pointing at left or right, just like the same as we say go to the left or go to the right. This is something I want to explain. But we separate it because there are two of the methods to active and make it to decide where to go. So yes.
Okay, very well. Okay, so thank you very much, the group Fitbot.
Yes.
For your presentation. So coming up, we have the team Botion from China as well. Yes, so you may share your screen. The team Botion. Yeah.
Hello, teacher. Can you hear me?
Yes, we can hear you and see you as well.
So we will start.
Yes, you may start now. 10:40. Yes.
Hello, everyone. We are the team named Botion from Xi'an Gaoxing No. 1 High School. The robot will introduce our team members to you through voice orientation and face recognition. Hello, Michael.
This is me.
Hello, Michael.
This is Shani Yelton. Hello, Michael. This is Tom Common. Hello, Michael. This is Ray Siwan. Hello, Michael. This is Jacqueline Shearer.
Next, we're going to do our final demo. Our theme is isolation at home. Please look at the data of these two pictures. We can see that the COVID-19 outbreaks has had a great impact on our lives. In most countries, isolation treatment is an effective measure, but the shortage of isolation rooms is also a difficulty. To solve these problems, we provide optimized home isolation, reduce human services, and reduce the risks of infection of close contacts. Please look at this picture. This is our whole scenes, and the Michael will first stand in the initial location, that's the green point, and our demo is divided into 5 main sections. Michael will go to the kitchen where he can get the delivery food, and when he take the food, he will knock the door and wait for the quarantine person to open the door. After that, he will go into the bedroom and to the quarantine person to do the nucleic acid and recognize the garbage and out of the bedroom, put the garbage into the recyclable can, and after that, at last, he will do the disinfection around the room. Now let's start our demo. First, order Michael to pick up the food and point the delivery location.
Hello, Michael. Go to the kitchen. I'm going to the kitchen now.
In this process, we build a map of the room beforehand and modify the incomplete parts of it. Finally, the robot is realized to work from one point to another.
Hello, Michael. Choose this one. Now I will do it for you.
We originally wanted to catch object precisely, but Because of the hardware problems, we could only achieve body movement recognition. We will do more efforts.
Hello, Michael. Hello, Michael. Go to the bedroom. I'm going to the bedroom now.
Michael will follow the map to the designated room and deliver the food.
Please help me open the door.
The purpose of meal delivery is to solve the problems of how to get food for the several of patients who are isolated at home. Follow, Michael will make nucleic acid for a quarantine person and recognize the garbage.
Hello, Michael. Food is done.
Michael put the delivery food down.
Hello, Michael. Make the test.
Now I will do it for you.
In-home isolates requires nucleic acid to confirm their recent illness. In order to realize the function of nucleic acid, we apply the robot arm and voice interaction module. Once the collection is complete, the robotics arm
Take away of the garbage.
Now I will do it for you. This is Roger.
Michael recognized the object is a bottle, so he will put the bottle into. In this part, he waits for the quarantine person to eat and take away the garbage. He is find the map and find the way to go out of the bedroom. Michael put the garbage into the recyclable can. After this, Michael will disinfect the environment.
Hello, Michael. Do disinfection work. Now I will do it for you.
Regular disinfection is necessary. When disinfection begins, all members leave the room. The robot moves to disinfect the environment. We equip the robot with a disinfection spray gun and connect it to the robot. Through the program, we can control whether it is on or off. Next, about mask recognition.
Hello, Michael. Have mask is have ma Hello, Michael. Have mask is Transportation.
We use Baidu AI platform. To recognize people's face whether wear the mask or not. And that's all our exhibition. Next, go back to our point. For ease of use, we have modified certain structures of the robot and added certain parts to be more in line with human-robot relationship. And the first one is lithium battery with transformer. It can solve the Adams power supply shortage and independent into the power supply. Next one is microphone array. It can locate the sound source and has an extremely strong noise reduction function for better sound source collection. And the last one is disinfection gun. And what you just say that in realizing the environmental disinfection, we use specialized disinfection equipment and with appropriate disinfection water. Yeah. And after that, now we are going to talk about our program characteristics. We believe that the adaptability of robots is very important. So we use a combination of online and offline. About online, we use Baidu AI platform, Pado online, and about the offline recognition, we choose here Costco to identify faces, objects, and environments, and Xfeel offline voice classification to recognize speech and synthesize speech. Okay. Although we have completed the process test of isolates robots, there are still some functions that are still incomplete. So we hope to make efforts to improve our isolations robots through further studies and research in the future, and apply it to our daily academic prevention life to benefit human society. At last, I would like to thank all the organizing committee for providing us with this valuable opportunity to discuss, learn, and share with all outstanding students. Thanks our teacher for his support and help to our project. And thank Liu Bosheng for his technical support. Thanks all members of the groups for their unity and cooperation. And that is all our show. Thanks all.
All right, thank you. Thank you, Team Botion. I think lots of efforts can be seen with that you really did a good job in very demo.
It almost includes all the scenarios in the quarantine situations. I think if I understand correctly, so you also include the PRC tests and disinfection solutions and so many things. But I think but in our real life, so the situation will not be that simple. Like, for example, if the robot delivers some things to the quarantined people, I guess the people must stay in different floor. So can robot take a lift to different floor? And I think this is something you should think before you conclude your project. Maybe you just specify in a detailed solutions, then do it very deeply. That will be much, much better, because in the real life, the situation will not be that simple. And also I see you do the disinfection solution. I don't know whether you combine the disinfection solution with the navigation functions. Like if the robot detect a person, will robot start, or they will continue to do the disinfection? I don't know whether you consider the parts or not.
Yeah. I got your situation. Yes, we know that in our daily life, the situation will be more complex. But our map is just a really simple map, and I know maybe different patients will in the different floor, and we can know that in most hotel, their robot will connect the elements, and yeah, we can do more efforts on it. But today it is just a simple and simple demo. We know that we have lots of less function, and we just to make our best to in the future to improve our program. And we believe that we can a robot can help the human to do more, do more human work during our daily life, to help
make us more convenient. Yeah, true. Actually, the idea is very brilliant. I think that's very.
We find this idea during our daily life, because we can see that there are some of these problems about our program. So we just want to do more help to help the humans asset us. Yes.
Yeah, and also what you have done is very impressive. That I hope you also can attend the competition next year. And when you prepare the competition for the next years, you can split the tasks into individual. Then you may think more for individual scenario, so that you can have a better solutions that can useful for the daily life.
Yeah. We will try our best. And to do more efforts day by day. Yes.
Thanks. I don't have any further questions.
Yes.
Thank you very much.
Thank you. We still have 3 more minutes. Do you like to share with us how do you distribute the task among your team members, like hardware, software, or is it by task? Because I saw you doing most of the talking, but I just would like to know like the responsibilities of your team members, or if they can just also tell us a bit of their experience so far. But just how you set up the team here, because I see you have 5 members now, right? Yes, I mean probably yes. Who is responsible for the hardware, who is responsible for the software, and who is responsible for the programming, maybe?
In this term, I mainly do the navigation program, and I do the main final field.
He's an engineer, engineer. Yeah.
Okay. And you have software engineering for the programming,
Yeah.
I'm the programmer of the robot arm, and I want to share something about my procession of the arm programming. First, at the first, we met some problems like the arm is not kernel convention. Each procession has a time to get, so there is some lag in it. So I write some procession change as procession change as a continuous function to let the program to program more simple, and and last we can only enter the target procession, and we will make that
yes. Thank you. Probably yes. A few quick words from the other 2. Yes, please.
I'm the capital of the team, so I'm very responsible for all things like director.
he made the plan for all our programs in the whole time. And actually, the parts of all the projects were made during our daily training times here. And we just have together parts, lots of parts in together in the last 2 weeks, and to do more again and again to improve our project during this time. Yes.
All right.
Yes.
Yes. Thank you very much, the team Botion. I think it's very, very good performance. Yeah. Thanks a lot. So let's invite the next team. So thank you.
Thank you so much.
Thank you. So the next team coming up would be the team from Beijing, Zichen Topic Maker. Are you here? Please share your screen and start your presentation.
Hi, can you hear me?
Yes.
Okay. So, hello, we are the topic maker team from Beijing number 35 High School. Ensuring the safety of the restaurant, we developed several functions based on the codes given by Robo at home education. There are the microphone switch, health kit detector, and gesture detector. During the early trials, our robot could not distinguish the voice command of the operator from the response produced by itself, and sometimes it misheard noises from the surroundings. So to solve this problem, we wrote a semi-automatic microphone switch inspired by the follower control, which uses 0 and 1 to control the following state. We wrote a function that publishes 0 and 1 to the send audio node, while the subscribe number changes, the value of the attribute changes, which switches the microphone on and off technically. Most of the publishers are in the main program Bartender, but when the robot is navigating, the published value is controlled by the navigation node. The value sent to the switch will be 1, while the robot reaches the set cell phones in public, indicating the holders are COVID-19 free. The HealthKit program can detect the green code and provide a safe catering environment. The RGB camera first captures the raw image and draws a rectangular frame around the green area. The distance between the camera and the health code display screen is calculated to ensure the correct detection. If the distance is smaller than a specific value, while the screen displays health kit code in front of the camera in more than 1 second, the robot would publish pass. In the previous competition, the judges reminded us about the time validity and the detail of the code. So we then harnessed the Tencent Cloud API in this program. We created a Tencent Cloud data bucket to store the pictures uploaded during the detection because this API only accepts online images. In this case, the time, COVID test results, code colors, etc. will all be detected to achieve the pass condition. The fourth part, gestures, common in daily life and contain many meaningful actions. Our program uses models from OpenPose, a cafe neural network model library, to detect and label the finger joints. The program sketches a minimally fitted circle and recognizes the hand gesture according to the relative position of the fingertips and the circle. Our robot can respond to a specific action set. For example, when a customer waves to the robot, the node will publish order or waving and trigger the navigation node. This program is not a finished product because the computing speed of the CPU is not fast enough, but we then turn to the Baidu API interface. The camera takes and uploads 5 images at a time to get the name of the gestures as outputs. In addition to those new functions intended to raise the accuracy, we also consider the real-time speech recognition on Baidu API. It recognizes the voice message according to the pauses in the sentence. Compared with the fixed rate detection in the original program, this is harder to control and be added into the logic clauses. So this function hasn't become the part of the main program. And the next part would be our real-time demonstration. Sorry, we have to restart the program. Sorry, the machine is run out of battery and we want to play the video we recorded. We are now demonstrating the health kit program. It must be green and negative test within 3 days to fulfill the condition here.
The result is
The result is printed on the screen. Let me do a screen share. Yep. Here. The color is green and the testing result is negative. So it published past year.
Okay, so the demonstration time is up. We have 5 more minutes. Let's move on to the Q&A, shall we?
Okay. Yes.
yeah.
Thanks.
Thanks.
So any questions from the jury? Yeah, but otherwise, the team may continue. If you want to add anything else or make some comments.
Can we like describe our script in general, like the
yes.
what the main program does?
Yes, sure.
Initially, it's like a restaurant robot, and it contains functions as both security robot and restaurant robot. As the security robot, it will detect the health code at the entrance of the restaurant, and then it let the customers in to the restaurant. Then it will let me show you my slide here. So basically, it will help carry the luggage, order and deliver the food, and it will guide the customers. Like we actually set table 1 and table 2, and it will guide the customer to table 1 first, and it will take his order, and then it will move to the kitchen. So it will communicate with both the cook and the customer 1. Then it will move to table 2, and it actually will recognize the hand gesture from customer 2, and it will recognize it and navigate its way to the customer 2, the table 2, and it will take its order.
Okay, or maybe you want to share with us just what actually happened during the demo that made you need to switch to the video recording. Is it a hardware issue or some technical problem that you have identified in the meantime?
It's software problem, I think. We're modifying the code like this morning, and yesterday we actually ran the whole program through, and we don't really sure what happened this day. Oh, and the API will have this limit free. So it requires
morning.
Yeah.
Yes.
Yes. All the function we mentioned before, like the health kit detect, the hand gesture, the waving detect, and the in-room navigation and recognition of speaking is they are all successful independent. They all run successful independently. But this robot is functioned today, so we can give this. So when we can give you this show, so we are very sorry.
No
You
worries,
can
it's
see
okay.
our technical video on the Bilibili.
Yes. Okay, so I think, yeah, we're finally coming to the end. Or Echo, or someone is doing.
Yeah, I just want to encourage the team.
Yeah.
I think the idea is good. Maybe next time you should make yourself be well prepared before the competition, then so that you can prove to us that you have a better demonstration and better work.
Yeah, definitely.
Yeah.
All right. So as such, we come to the last tip of this morning. Open category for open platform for the junior category. So I would like to invite Jeffrey to take back the floor. Yeah.
Okay, right. Thanks, Jerry, for the judging as well as hosting of the event. And also thanks all the teams and also thanks all the jury member that we have very, I can see like very exciting project presented. And also it's a good job that all the junior member actually trying very hard and also show very nice presentation this morning. Although we have some problem here and there, but at least I think like everyone have tried their best and show all the very interesting ideas, and also like hopefully we can interact more with the jury after this, so that we can see what else that we can improve from now onwards. Right. So thanks a lot all the parties, and I would like to come to the closing for this session. So maybe let me switch over my slides. So maybe for the last tip, yes, you may want to like stop your sharing. Okay, right. So now I have more time to make the closing for this session. So I'm Jeffrey, I'm back here. So today we have this open platform final for the junior team, and today total we have 7 teams, and we have also teams from as far as US and also Canada, and also some teams from Asia here. It's a very nice event. So today we do this similar like our previous event. We do this open challenge virtually online, but we already recorded on all the session, and we are going to share it on our social media after. We actually have teams as far as from Canada and also from US, and also we have many teams from China as well. And they are all middle school and high school students. So they are actually between the range of the age of 14 to 19, if I'm not mistaken, right? And they're very young for at-home development. So it's a very good performance, and also it's a very good development that you have shown this today. Right. So this was the schedule. As you can see, like we actually determined the schedule using drawing lots during the setup day, so that everyone actually come in a fair manner to do the presentation. But of course, due to the time difference, we actually give priority for the teams from North America, so that they can present first, because like I think the time is pretty late over there. All right. So for today's jury, actually we have two sets of jury. So one is from the internal and another one is from the external. And the internal jury member is taking care on the technical side. So because like for this at-home development, we focus on building service robot. So for service robot development, it is meant for the general public because the service robot meant to serve the general public. So slightly different between these two, right? And also we have done our presentation. So each team actually have 20 minutes, 15 minutes for presentation and also robot demos, and also 5 minutes for Q&A. And the presentation mainly we focus on the robot demonstration and technical explanation. But we can also see like this time, because like I understand that still many parts of the world having this COVID restriction. So some of the team actually not able to gather in the school or in the labs, and they're not able to actually do the full presentation using the robots. But we can see teams still try their best to show some of the robots, to show some simulation, to show some work on the PC, and also they presented like maybe everyone remotely from different places. So we hope that this online platform will actually continue to give a good platform. We're not sure how far or how long this condition will continue, but at least with this online platform, we can still manage to allow our community to continue our development. So we will still keep on learning, we'll still keep on developing and improving ourselves without actually restricted by the current situation. But of course, this safety measure also to keep everyone safe. So over here, I really hope like everyone is safe and sound, and we actually together to do the robot development in a very safe environment. Okay, so I'll come to the last slide for my closing remarks. So I would like to introduce the jury member today, and I would like to invite them to introduce themselves and also to give some advice or comment or any feedback for the team so that they can actually improve from now onwards, and hopefully next year they can show a better performance. Right. So first and second also so for the first and second jury, so we have Luca and also Amy. So they are the trustee of the federation, and they are very experienced RoboCup member. So they act as our jury chair, but unfortunately they can't actually attend live this morning because they are actually on the way to back up for the event next week, right? But they are going to review the videos, and they are going to like give them their judging, right, based on the offline method. Okay. Then also we have Professor Yoshinobu Hagiwara, and he is also currently like not available for this morning, but he will actually join us this morning, this afternoon, for the open platform, open category, right? Okay. So now I would like to call upon the next one, Ms. Eiko Chiu from SoftBank Robotics China. So thanks a lot for supporting us in terms of the SP, and today also attend this online session for the OP teams. And I would like to hear from you from the perspective from SoftBank to see how what kind of comment that you can give for the OP team, and also how this thing can actually help to improve the SP development in future. Right, so please, Echo.
Thanks, Jeffrey, and thanks for the invitation. And it's my pleasure to join today as well. Actually,
right,
today,
Echo, maybe you can
yes.
We can't hear you yet.
Hello, can you hear me? Hello.
Yes.
Okay.
Echo, we can't hear you.
You can? But,
I can.
Yeah.
Okay, right. Okay, good.
Okay, so actually it's an impressive morning. Some team bring some very brilliant ideas, and some team bring very good works. Actually, there's many teams. I don't want to comment one by one. Actually, I already comment during each demonstration. So I just want to share the most impressive idea is from the one school in Xi'an province. And they create very good scenarios, and they almost including all the situations in the quarantine scenarios. I think the idea is very good because they observe the daily life very carefully so that they can have this brilliant ideas. But the technical side, I think they should think deeper so that they can have very, very good solutions in the futures. So if they can do it better in this part, and I think it will be it will bring the value to the life of the whole society. Yeah. Other than that, I think some teams is doing the standard work, like the carry the luggage. Some team explain their code very carefully, but I guess there's some problem of the internet or something of the software or something. We don't know. The demonstration is not very good, and I think maybe each team, if they want to attend this competition, they should get himself well prepared. Otherwise, they may lose the chance to win this competition. Yeah, that's something. Yeah, that's almost everything from my side. Thanks.
All right, thank you. Thanks, Aiko. Right, so next we have Dad from Jupiter Robot. So please come, if you possible, for you to turn on your camera and introduce yourself and give some comment to our teams.
All right. Now this is Dante from Jupiter Robot. As you may know, Jupiter Robot is a company that develops educational robots, and I was glad to see teams using our products, the robot or the finger detection, and robot for mail ordering, book management, and the housekeeper robot, and the quarantine robot. Yeah, it's impressive, isn't it? Thank you.
All right, thank you very much. Thanks a lot. Okay, so last but not least, I would like to call Jerry. Thanks for your help for the hosting just now, and also please introduce yourself and give some comment to the team.
Yes. So hi everyone. So I'm Jerry. So it was a great pleasure for myself to join as a jury member to experience the online challenge myself. I think roughly the advice that I can give to the team is that they really need to maintain the balance between like storytelling, explaining the scenario, as well as the explaining the algorithms and the coding part. So I see that there are a few teams that probably are spending a bit more time on trying to tell the scenario. But it is good as storytelling, but after all, we are still also very much interested in learning more about the thought process, the programming part as well. And then I would also like to share with the fellow jury members about we do need to be aware of the fact that some of the teams are not able to bring their robots for the demo, and this could have impacted the overall performance of the demo. It was a difficult thing to do actually, if they have spent months working on the robot but suddenly could not really show the robot on the final day of the presentation. So I would like just to remind ourselves to take this into consideration when we are awarding the points. But overall, yes, keep it up. I think they are very bright, because if they're just junior category, but I think it's very, very impressive performance that we saw this morning. Yeah, thanks a lot.
All right, thank you, Jerry. Thanks a lot. And with that, we have come to the end. All right, thank you, Jerry. And with that, we have come to the end of the session. Right. So once again, I would like to thank everyone joining us, all the team, all the jury member, and also all your support. So I actually look forward, and we at RoboCup at Home Education, we really hope that this platform will inspire and also motivate more junior team, more young generation students to take up this very complicated at home development, to learn more about AI and robotics development. And we look forward next year to have more teams to join and more interesting projects presented next year in our RoboCup at Home Education Online Challenge next year. All right, so thanks a lot, everyone. And just as an announcement, so we will actually publish this video later on our social media. And this afternoon, we actually will continue the open platform final for the open category, which is the university student teams will join. So again, we will have another 7 teams, and I can expect like very interesting projects, and also robot demonstration is awaiting us. So let's just take a break for the lunch, and then we will come back just maybe 10 minutes before 1 p.m. Local Thailand time, and we will start our online platform final for the open category. Thanks a lot, everyone, and I will see you again. Bye-bye.
Thank you. Bye-bye.
Bye-bye.
OK， 好，谢谢大家 ，Thank you。我们下午1点之前再见。Okay, so I will end the meeting.